This retrospective account of the construction of a major telecommunications link was made by the Australian Post Office, which in 1975 was split into two commissions, the Australian Postal Commission and the Australian Telecommunications Commission, or as they're better known, Australia Post and Telecom Australia. Today, Telecom Australia continues the work of construction and extension of further links in the national broadband network throughout the nation.
Edward John Eyre had a vision. He dreamed there was a way over the barrier of wind-sculpted sandhills, along cliffs dropping sheer to the desolate waves of the Southern Ocean, surging into the great Australian bight to beat on one of Earth's loneliest shores. Through more than 2,000 kilometers of salt pan and blue bush and stunted scrub, Eyre dreamed and endured, and over a century and a quarter ago, found a way. For more than 1,600 kilometers, the Eyre Highway now pierces the barrier of this harsh land, the only direct road link between eastern Australia and the west. It cuts a lonely path through dust and scrub and saltbush, and for 650 kilometers skirts the southern fringe of the great treeless plain, the Nullarbor. 130 kilometers north, one of the great modern trains of the world, the Indian Pacific, cuts across the desert as it spans the continent from Perth to Sydney. The Aborigines have a word for the people who live in this lonely region: longa kalonga, far away from each other. They may come from the isolated settlements and sheep stations into the scattered townships, but there is still a deep sense of remoteness from the rest of the world. In inhospitable land where explorer Eyre reported in 1841 there was not one single watercourse in 1,400 miles. Precious rain feeds no streams, but lies wastefully before seeping back into the thirsty earth. A harsh land that has broken the hearts of many a pioneer. Even today, it needs a stout heart to wrest a living from this dry country, where it may take as much as 25 hectares to support one sheep. Contact with the outside world is rare enough for it to become a family affair to collect the mail from a passing truck. The first bid to end the isolation came in 1877, 5 years after the rest of Australia had established telegraph links with the outside world. It was then that the single iron wire was strung along the path that Eyre had trod to the west. Through these stations, where telegraph crews and their families lived in landscapes as remote as the moon, the incessant chatter of Morse code carried through the desert for 50 years, a tenuous link between Perth and capitals in the east. 1927, the new telegraph, 3 lines opened along the Transcontinental Railway. 1930, the first telephone circuit, voices, east and west. The circuits multiplied, but the demand for communications grew faster. There were delays in traffic. Something new was needed. And in 1968, something new appeared. The technological age came to the desert. The lofty towers of microwave radio began to march with giant strides across the formidable land, finally to break the communications barrier. "60 towers, up to 40 kilometers apart, have bridged the desert gap between Port Pirie and Northam. They complete the nationwide broadband network of coaxial cable and microwave systems, bringing subscriber trunk dialing, television relays, and telegraph and computer data traffic to people as far apart as Carnarvon and Cairns." In the microwave system, unlike ordinary radio, there must be direct line-of-sight contact from antenna to antenna to channel the silent stream of signals flowing through the air. Towers must be set zigzag so that signals cannot overshoot and cause interference to other stations further down the line. The stream of telecommunications traffic picked up by the antenna is reflected into a feed unit and channeled down the waveguide into the electronic heart of the repeater station. Here, complex equipment amplifies the messages and feeds the signals out to be beamed with new strength to the next tower. Traffic can be handled both ways simultaneously. At any moment, each antenna may be both transmitting and receiving many hundreds of voices, signals, and images, each message kept distinct, sharp, and clear. In harsh terrain, virtually unchanged for centuries, a silent reminder of the past marks the way men had to go in their search for the best path for the microwave link to follow. Telecommunications linemen and technicians moved in, and rugged pioneering work became the prelude to the operation of electronic test equipment in these desert areas. Microwave signals can behave erratically in the fluctuating and shimmering atmosphere of the Nullarbor, and a long series of radio propagation tests were automatically recorded, then checked and analyzed to help choose the most suitable radio path. Meanwhile, the new explorers of the technological age, men from the Department of the Interior, went into the wilderness to carry out a survey over the proposed route. The ground parties, working painstakingly through the most difficult country, made pinpoint chartings in the remote areas, the first such surveys ever made. As each section of the groundwork was completed, a survey aircraft took off from a desert strip. Guided by smoke pot markers, in a few minutes, it swept along the path that ground parties had labored over for weeks and charted it from the air in a series of stereo photographs. The portrait of an unlovely land, warts and all. Together with the ground surveys, this produced the first fully detailed contour maps, a vital factor in deciding just which way the microwave towers would stride through the arid barrier to the west. With the course charted, the construction crews moved in with their heavy equipment, and thousands of tons of steel and cement were freighted into the desert. Techniques new to Australia were used on the foundations. They gave great strength together with economy of materials, particularly cutting down the use of concrete, difficult to prepare in this waterless land. A 23-centimetre drill biting down some 10 metres into the limestone gouged a shaft for the taproot that would anchor the steel mass firmly to the earth. A bound sheaf of high tensile steel cable is the core of strength in the foundation of stressed concrete built up in the shaft. Partly cemented, the cables were twice within a week brought under stress with the aid of a compressed air jack, checked that they were held firmly in the ground, then locked at this tension in a seal of concrete. When completed, only the immensely strong stub and anchor bolts remain above the ground. With the foundation bedded deep into the earth, the squat base legs were swung into position. There may be up to 60 tons of steel in the framework of a completed tower, which must be capable of withstanding winds of up to 160 kilometers per hour. With the stocky legs in place, diagonal and horizontal bracing framework could be swung into position. This is a job for experts, and these men brought to it the skill of steeplejacks, or circus performers. Following a smoothly established plan, these teams took between 2 and 4 days on each site to assemble the long line of towers across the Nullarbor. But to supply and maintain the teams in the field, to move the fleet of heavy vehicles, cranes and equipment, and to transport the huge weight of steel along the construction line over the desert was a major exercise in logistics. The 59 towers ranged in height from 23 to 76 meters. The giant crane could lift pieces of the frame up to the 45-meter level, but beyond that a jury rig was used to hoist up the galvanized steel to complete the loftier sections. And so the towers rose in the desert, the link passing through this Aboriginal reserve in South Australia. And the children who get their schooling at the mission heard a basic lecture on microwave to explain what they saw happening in their land. Telecommunications, along with traditional handicrafts. In this harsh climate, special buildings are needed to house the heart of the system, the repeater equipment that amplifies and maintains the strength of the signals flowing between the antennas. Each dust-sealed shelter to house the delicate equipment was delivered as a complete unit. Around this was assembled a prefabricated, insulated building acting as a sun shield and designed to utilize a natural airflow, entirely supplanting air conditioning, which would have been too costly. Maximum protection is essential in a region which may vary from 50 degrees Celsius by day to a freezing -4 degrees at night. Meanwhile, factories in many parts of Australia were in production with various items and installations essential to the project. Heavy diesel generators and intricate control units for the power supply were manufactured in Melbourne. The use of printed circuit boards and sub-assemblies combined simplicity and efficiency in contributing towards the vital power requirements of the completed system. With no mains power across the Nullarbor, each station must be self-sufficient and produce its own power. Banks of batteries provide a direct current source from which the repeater equipment is fed. These are charged by a dual system with the flashing 4-meter blades of a wind generator providing a backup to the sturdy diesel units. The solid parabolic antennas, the largest ever manufactured in Australia, again called for new techniques to be used in spinning the aluminium sheets. The inner surface of the bowl has to be spun precisely, with only a 3mm variation allowed from its specified shape. Then a framework is fitted on the back to keep the dish rigid and to provide a base for fastening it to the tower. At the telecommunications laboratories, prototype equipment from Britain underwent stringent tests in artificially created extremes of climate to ensure that it would perform well in the Australian environment. All this equipment is fully transistorized using solid-state devices. This modern technique conserves space as well as meeting the requirements of low power consumption and has contributed enormously to the revolution in telecommunications. With new equipment coming in, special classes had to be held to train technical staff at all levels. Engineers from the company supplying the equipment conducted courses to familiarize telecommunications technicians with all the theoretical and operational aspects of the microwave system. On the site, new knowledge and apparatus were used in the final adjustment to the antennas before they went aloft. As part of the test, a photographic record was made of each antenna's performance to be used for any necessary readjustment in the future. Steadied by ropes, the big dish was slowly winched skywards, and while a constant check was maintained from the ground, it was swung in to be fastened to its lofty tower. Each antenna must be carefully aligned to aim accurately at the one on the next tower. Portable equipment is used to send a test beam between the two antennas, which on the Nullarbor are up to 40 kilometers apart. Manipulation brings the big dish into alignment. The final adjustment is made, and when the meter shows maximum signal, the antenna is locked into position. This is the artery of the microwave system, the hollow corrugated copper tube, the waveguide. It must be handled with great care, for it carries the two-way stream of traffic simultaneously received and transmitted by the repeater station. The tower end of the waveguide is locked into its collar on the side of the antenna, and a final tuning matches the performance of the waveguide to the complete network. In the multiple hearts of the system inside the repeater stations, the installation of microwave radio equipment was rapid. Much of it is in fully assembled units which plug straight into prepared racks, greatly simplifying maintenance. Many safeguards are built in to ensure continuity of transmission. If there's a fault or breakdown, the equipment automatically switches to another circuit in a fraction of a second, so quickly that there's no noticeable break in traffic. Many of the lessons learned in building this system have made significant contributions to the development of microwave networks in other parts of the world. In stations such as Ceduna and Norseman, monitor equipment keeps an electronic eye on all other stations in the chain. You can see at a glance the state of electrical charge in the batteries hundreds of kilometers away, when the generators are operating, the level of diesel fuel, whether the services of a technician are needed, and even his arrival at a distant station is signaled back. So, in station after station, the final checks are made on the complex equipment, and the way is opened. The signals began to flow between the lofty towers, which brought the great cyclops eyes of their antennas to bear across the shimmering plain. The east-west barrier was finally broken by this highway of telecommunication across the desert from Perth to Adelaide. The land returns to its ancient seclusion, but across it now streams a great silent flood. Telephone calls, telegraph and telex messages, computer data, radio and television relays, giving the West full and direct communication with the East, and through Earth stations such as that at Ceduna, satellite contact with the rest of the world. The Nullarbor link can handle more than 1 million phone calls a year. It constitutes a major section of the national broadband network and means that people can pick up a phone and dial direct to most other places in Australia. The benefits of one of the most modern communication systems in the world have been brought to communities throughout the land, to the once isolated station owner on the Nullarbor, to the desert city of Kalgoorlie with its Golden Mile, to vast industrial enterprises such as BHP at Whyalla, to mineral boom towns of the west such as Kambalda, and to remote townships scattered over vast distances of the continent.
Hello, Joe. You know those stock we're talking about? Well, look, Joe, these stock are really hungry. I want to track down 500 head for adjustment.
Mr. Rayner, would you buy me 10,000 Minowa minerals? Yes, that's right, with options.
Well, I
No more
don't
than
follow
a
the recipe exactly. I dropped the garlic and...
It's a
just
boy!
a touch of-
9.5 pounds. Everyone's fine. Except me.
You catch that 9:30 plane, you can be here before lunch. It's a vital meeting, and I'll have
Oh,
the car
that's
meet
you,
you
Mum?
here.
We've arrived home safely. A wonderful trip down the coast. And
Darling, I'm
Ken-
sorry it's raining there. Weather's beautiful here in Perth. Incidentally, will you marry me?
This is the National Network, ABC Television in Sydney, relaying to Brisbane, Melbourne, Hobart...
Edward John Eyre had a vision. More than a century ago, he saw a way clear across Australia. Now it is a reality, although in a way he could never have foreseen. The way is open east to west, but young people to come will have new visions and meet new challenges. And in the world of communications, of developing electronics, satellites and laser beams, the challenges may be met and the visions realized in a way we cannot now imagine.